Yes, hi students. In this video, we will learn building custom object detectors as an important concept in computer vision and image processing, right? So, object detection allows computers to identify and locate the objects within an image or videos where it is locating either in image format or in the video format, right? Custom object detectors are identify to design and detect the specific objects based on the requirements of the particular applications. Based on the applications, will be detecting, right? Such as, for example, we can say for detecting vehicles or in animals or human beings, whatever it may be. So the first thing is what is actually object detection. So object detection is the process, right? Process of identifying the objects in an image, right? And not only identifying the image, the basic thing is identifying the image as well as identifying the location also. So determine first thing is identify the image and second thing is determine the location. So this is not like only image classifications, right? So object the output of these object detections usually what we can include, it will be included as the objects like the car, a person, or specific animals like a dog or cat. So the second one is that will be specifically displaying inside of the box, bounding box. Will be find the location, exactly finding the location, and will be showing us the inside of the box, right? So the object detection is widely used in self-driving cars or surveillance systems or automatic automations wherever it will be there. The areas it is suitable, and robotics also playing in the robotics area also it is playing a role. So, what is a custom object detector? That is the question, right? So, the custom object detector is a model trained, that model is already trained to detect the specific objects. There is a custom object, right? It is these models not included in the standard data sets. Example, what we can say is normal a company we can say is the example it found to detect uh, um, in that company products or the parts of the manufacturing process. Example, we can say in agriculture, some disease in a plant you want to detect it, and some animals, wild animals, that all things we can see in the examples, right? So, for detecting what are the steps we should follow. So, steps to building a custom object detector. The first stage is first thing we have to collect the data. Right? Data collection is the important role. What are the data necessary to detect it? So that everything will be collected, and that will be including the image. Consist of different angles or will be not different conditions. Weather conditions may be vary, lighting conditions may be vary, the backgrounds may be vary. So all things you got to analyze to improve the accuracy. Right? Then the next stage is data annotations. Data annotation is like each image or object may be labeled by drawing some bounding box. Right? So for identifying the locations, that will be indicating the locations of the objects. So that people call as that labeling or CVAT because commonly we use the term as. The third stage is data processing, pre-processing. Pre-processing in the sense we are making more accuracy, like removing the unwanted noise and training the data that a data will be prepared for training, right? Resizing or normalizing or augmenting. This augmenting specifically, you can say it will be including rotation, clipping, or scaling, these are things, right? So on the next stage is model selection. We select the model. Which model? Model is some algorithms to do the object detection. Right? Few algorithms is there. Based on our needs, we have to select the algorithm. So first one we can select is the YOLO, you only do once. That is the algorithm. And the second one is SS, single shot detector. and we thought we can use a faster or SEN, and these are the algorithms we have. So based on our requirements, we select it for um, finding the model. Right? And next one is model training. After selecting through the algorithm, we annotate, um, uh, train the data for the model. So it will be detect automatically by the algorithm. That what we want to detect, that will be doing the processes automatically. So next processes evaluate the data, evaluations, right? After training the data, you have to evaluate it using for why we are evaluating for getting the accuracy, finding the accuracy level and precision level and recall level and mean average precision level. These are all things we want to find by um, in the evaluation stage. Right? After finding these all things, finally, trained model will be deployed into the applications. Just wherever we want to apply, we can apply mobile applications or surveillance systems or industrial automatic systems. So, various applications are there for using this customer object detections in real life. In the real life world, example, we can use autonomous vehicles, like self-driving car, for finding pedestrians in area or traffic signals vehicles. In the medical also, they're finding using for detecting the tumors and what retail systems for find the product identifications, or in agriculture, find the plant disease, right? That pest anything is there, that everything can find. So and so whenever using this object detection, using these various algorithms, even though applying this other technologies, some challenges maybe we face, right? So the challenges, what are the various challenges maybe there when using this custom object detectors? Large, we need a large amount of label training data, right? So that is the challenge first. And the second one, you can see the variations of lighting or the temperature or the background settings. It will be difficult to find the object exactly, the accuracy level. And the third one is object occlusion. Some parts may be hidden by some background distractions or some climatical distractions. So these are things we may face while detecting objects as challenges, right? So, in summary, we can say the object detector or training model that identify the specific objects in an image, and the first steps for doing that, we have to follow the steps as data collection, annotation, model training, evaluation, and the deployment. Then these all things using in the real life as what AI-based automation, some robotics and healthcare, and also overall industrial applications too. Okay, so thank you for watching.